Welcome to part 2 of the scientific method alternative exercise for biology 131. This is using the scientific method. Remember that science is an attempt to understand and explain the world we live in. And one approach to doing that is the scientific method. The scientific method is a process used by scientists to investigate the natural world. And in fact, everybody really uses the scientific method, even if they don't know that they're using it. Aside from scientists, I would say that the two groups that use the scientific method the most are auto mechanics and babies, and we'll come back to that later. The scientific method looks for causes and explanations for observations that have been made. The scientific method is rarely used in a rigidly structured form. We're going to present it here as very linear and stepwise, but in reality, it's more complicated than that. If you were to go into a research laboratory, for example, and say, "Hi guys, what step of the scientific method are you on?" they would probably just look at you funny because they don't use it in a rigidly structured linear form. And in fact, it's so ingrained into the way that scientists think that they don't even really think about it that much anymore. So the first step of the scientific method is one that you've already met, an observation. So what's an observation? I hope you said something you can sense, something you can detect with your five senses. So that's where the scientific method begins. So a person makes an observation, and then what do they do next? They formulate a question. They're looking for some explanation for the observation that they've made, right? The next step in the scientific method is one that I'm sure you're familiar with. You've heard about it before, and it is to formulate a hypothesis. So what is a hypothesis? A hypothesis is a tentative, that means like sort of temporary, possible explanation of the observation. And we already met a hypothesis in sort of a broader form when we learned about inferences. Remember that a hypothesis is a generalized inference about a group of observations. Now, in order for a hypothesis to be considered scientific, it must have one very important characteristic. Do you know what that is? What characteristic must a hypothesis have in order to be considered scientific? It must be testable. What does it mean, testable? That means there must be a way you can test it to see if it is so. Now be careful, because testable is different than tested. What's the difference? Tested means it already happened. A hypothesis can be a scientific hypothesis even if it's never been tested, but it must be testable. There must be a way you can test for it. So what do we mean by testable? Well, we mean there must be some experiment you can do to see if your hypothesis is supported or if it's not supported. Not supported, we usually say the word refuted. Refuted means it's not supported. Please know that scientists really do not use the word proven when they talk about a hypothesis, because proven is really final and it makes it sound like, okay, we're done with science, shut off the lights, we can all go home, we proved it. And generally speaking, scientists need to keep an open mind in case there's maybe a new way to test this hypothesis that they hadn't thought of before. Okay, so typically we say supported or refuted. Okay, so when we talk about testing a hypothesis, we mean it has to be testable in the physical world, in the physical realm. So there must be something we can do, or we can make some more observations, and again, observations involve our five senses, that will help us determine if the hypothesis is supported or not. So it's important to realize that this means that the supernatural is outside the realm of science. Okay? So I want to digress a little bit here and talk about this. Sometimes people perceive that there's a conflict between science and religion. And in fact, I don't believe that there is one. I think it really occurs because people don't entirely understand science. So if I were to ask you what religious faith means, what would you say? So generally speaking, when we talk about religious faith, people talk about believing in some higher power that they cannot see, right? Believing in something which is unseen, which is not right before you, which is not of the physical realm, okay? Something spiritual. Can you test for something like that? Can you test for something that you cannot sense with your five senses? Can humans test for the presence of God? No, because those sorts of things would be outside of the physical realm. So if something is outside of the physical realm, it is not included in a potentially testable hypothesis because there's no way to collect data on it, okay? So science doesn't say religion is bad or there is no God or anything like that. What science says about the spiritual is nothing because that's outside of the testable physical realm. So when we formulate a hypothesis, it must be testable in the physical realm. Once we have developed a hypothesis to explain our observation and answer our questions, and we've determined that the hypothesis is testable and therefore scientific, we design and execute some experiments. The experiments are a way to test the hypothesis, and during the course of the experiment, we will collect data, which are pieces of information or observations. So we will do this experiment and we will have some results, which we then use to draw a conclusion. So the conclusion is an analysis of the results of our experiment as to how they reflect on the hypothesis. In other words, do our results support the hypothesis, or do our results refute the hypothesis? Now, in a real science setting, scientists don't just do an experiment once and then say, yes, we've supported our hypothesis, or, oh, we've refuted our hypothesis, let's go home. They would do the experiment again and again and again and again, because the goal is, this is a search for truth. So in order to be sure that you're really seeing what you think you're seeing, it's necessary to repeat the experiment many, many, many times. On page 3 of your lab, you have a table that says steps of the scientific method on the left side, and in that left column, you want to now list the steps of the scientific method. Now that you know the steps of the scientific method, let's apply them to a non-biological example involving a car. So on the table on page 3, in which you wrote the steps of the scientific method, you'll see there's a column on the right where we can work through this car example. So let's get started. So what's our first step? Make an observation, right? So imagine you go out to your car, turn the key in the ignition or press a button if your car is new and fancy, and you find that your car does not start. You can observe that, correct? You can see that the dashboard is not lighting up. You can hear that nothing is happening with the engine, and you can feel that the motor's not running. So those are observations, right? What's the next step after we've made our observations? We want to ask a question, right? I think the obvious question here is, why doesn't my car start? Now we're going to formulate a hypothesis which is meant to answer that question, okay? Remember, it must be scientific. All right, I don't know a lot about cars, as you will see shortly, but I do know that there are different hypotheses that can be formulated. Now remember, a hypothesis is an inference, and you know that not everybody will make the same inference based on the same set of observations. So write down a hypothesis, which is scientific, that explains why the car doesn't start, okay? All right, my first guess was the car is out of gas, because again, I don't know a lot about cars. Is that a scientific hypothesis? Yes, it is. Why is it scientific? Because it's testable. It is possible to test this hypothesis, okay? Is that the only possible scientific hypothesis? Certainly not. The battery might be dead. Is that scientific? Yes, because it's testable. The starter is broken. Scientific? Yes, because it's testable. How about this one? One of my students put a curse on me. Don't think that hasn't happened. Is that a scientific hypothesis? No. Why not? Because it's not testable. We have no way to test for that. So we're going to get rid of that one. Okay? So I'm going to actually pick the first scientific hypothesis I chose, the car is out of gas. Okay? What's my next step? The next thing I'm going to do is test my hypothesis by putting gas in the car and trying to start the engine. So imagine I do that and my car starts. Yay! What does that mean? What is my conclusion? My conclusion is that my hypothesis was supported. The reason my car didn't start was because it was out of gas. What happens though if I put gas in my car and the car still doesn't start? It means my hypothesis was refuted. It was not supported. So what do? I go back and I pick another testable scientific hypothesis. Now, because this is a very concrete example where I'm just trying to get my car started so I can go to work, I wouldn't feel the need to repeat this experiment. But again, if this were a really constructed scientific experiment in the laboratory, this would need to be repeated again and again and again. Now, you might remember a couple slides ago, I said that auto mechanics use the scientific method a lot. So think about what happens when you take your car to the auto mechanic. You take your car to the auto mechanic, and what do you say to the mechanic? Or what do you write down on the form? You write down a set of, or you say a set of observations, right? I'm hearing a weird noise when I turn the wheel. I smell something burning in the car. I see this smoke coming out from under the hood. Aren't those all observations? Because you're using your senses, probably not tasting, but you're using your other senses, right? So what you do when you take your car to the auto mechanic is you present the mechanic with a set of observations, and then what does the mechanic do? The mechanic will formulate some hypotheses. The question, I guess, is what's wrong with my car, but the auto mechanic will formulate a hypothesis that is testable and then spend the day testing the various hypotheses until he or she determines what was wrong with your car. Okay? So auto mechanics use the scientific method all the time. Babies also use the scientific method. How do babies learn about the world? They're constantly doing little experiments, right? They're touching things. You know how they put things in their mouths all the time? So this is a way that we all learn about the world around us. We just don't think about it in such a structured way. So the scientific method is really structured logical thinking with the goal of trying to explain something. Now it's your turn to work through the steps of the scientific method with a biological example. So on the bottom half of page 3, you see a table that says example 3. Here's a picture for you to make an observation about. So please make an observation about the little sprouts that are growing in this jar and write that on one of the lines, the first line on example 3 table. What's your next step going to be? Ask a question. What happens next? You're going to formulate a hypothesis to answer your question. Make sure that your hypothesis is scientific. Make sure it is testable.